Alright, so again, today we're talking about domain and range. You'll be able to identify functions and state domains and ranges. So you're going to be able to tell which relations are functions. You're going to be able to find the domains and the ranges of those said functions. So a relation is a set of ordered pairs. Okay? You guys know ordered pairs. You've been dealing with them ever since you learned about plotting points. Okay? Ordered pair like 1, 1, negative 2, 5, so on and so forth. Okay? A relation is a set of ordered pairs. So multiple ones together. Now a function is a relation in which no two ordered pairs have the same x values. So if you look at a set of points, okay, and you do not have the same x value amongst those ordered pairs, then you have a function. However, if you have 2 points that have the same x value or 3 points that have the same x value, it's not a function. Okay? So those are two definitions there. Two main definitions here. But no matter what, you can always find the domain and range of these, whether it's a relation or a function. Okay? Now, x is the independent variables. Okay? So when you look at your ordered pairs, you have an x and you have a y. Alright? The x is the independent variable, also known as the domain. And then the y is the dependent variable, also known as your range. Okay? And if you're wondering what's this little thing off to the side, you don't have to draw that. That's what this is that's in my hand. Alright, so if you're watching this video, what you need to do is you need to pause it right here. You need to go and look at the add-in video that kind of goes over that extra handout and how to find domains and ranges from a graph, a map, ordered pairs, as well as a table. Okay? So pause this video so that way you'll kind of be in order. Now, hopefully you watched the video, so now we're back to finishing off the domain and range notes. So we're trying to figure this out algebraically, how to find the domain of a function. In all honesty, the domain of a function is all the real numbers where the function is defined. Remember, we were looking at the graph. You're looking at where the graph actually, what x values the graph actually includes. That's where it's defined. When you're doing it algebraically, you pretty much need to figure out where is it not defined, because it is everything else but those values. So, where a function might not be defined is where the denominator equals 0, or where you have a negative number under an even root. So we're going to look at about 6 examples just so you guys can have a variety of how to find the domain algebraically to help you when you're, in the future. So we're going to look at these 4 right here. So for the first one, f of x equals 2 plus x over x squared minus 7x. Okay? Right here, anytime you see a fraction, you already know what number cannot be in the denominator.
0.
A 0. Okay? Is there a square root at all anywhere? No. So the only thing you have to really worry about is the denominator cannot equal 0. So your domain is going to be every real number except where the denominator equals 0. So what number is that? You take the denominator and you set it equal to 0. Now you do have to do a little bit of a throwback here. And you're going to have to do what? Look, I heard you say. You're going to have to factor. Okay? Now, think back to factoring. Does anybody remember what's the first thing you look for when you factor? Squares. The very first thing. They're kind of like in the same ballpark. It's 3 letters. Who's that? GCF. What's that stand for? Greatest common factor. Do these 2 things have anything in common? X. Okay. So you take that x and you factor it out. When you factor out an x from an x squared, what are you left with? Okay. All right. So over here is going to be a minus 7. At this point, all you do is set the outside equal to 0 and the inside equal to 0. So x equals 0 and x minus 7 equals 0. So here's one. If x equals 0, my denominator is going to be 0. Can't have that. And if x equals what number here? Here. Positive 7. You add 7 to both sides. Wow. Okay? So if x equals 0 and x equals 7, then it's going to be undefined. So then, to find your domain, honestly, I like to use set in this case because I did all this work. All you have to do from here is include your notation for set. And I want all the values where x does not equal 0 and where x does not equal 7. And then, of course, you got to remember to include your x is the element of what type of numbers? And that's it. Okay? This one is, yes, it is a little bit longer because we're given an equation here versus a graph or map or table. Okay? So, in these cases, we set the denominator equal to 0 and we solve it out normally. Once we figure out what x equals, we just put a slash through them and include our notation. And that's your domain. Now, if you did it in a set, you would have like 3 things. You got to do everything plus 0 and 7. That's too much. I mean, not set, I mean interval. That's a lot. And you got to remember your symbols too. Parentheses and brackets. Let's do B. Okay? We're going to do all four of these together. I want you to try 2 on your own. Now, B. What can you not take the square root of? A negative number. Very good, Nicholas. Now, so can I take the square root of 0? What's the square root of 0? It's 0. It is 0. So, when you have a square root, whatever's underneath the square root, you're going to set it greater than or equal to 0 and solve for your variable. How do you solve for t? Add 5. And that's your domain. Everything that is greater than or equal to 5. And you know we can easily just put this in set notation, right? What do I need? T is such that t is greater than or equal to 5. And then t is an element of what types of numbers? You can also do an interval, of course.
So when you put the greater than or equal to 0, it takes away the square root.
Because we're only concerned about the values that are going to give me a 0 or anything like a positive number. Okay? So, just to recap. When we have a denominator, we set the denominator equal to 0, solve, and then we put slashes through our equals. When it's a radical, we set whatever's underneath the radical greater than or equal to 0. We solve, put this up. Okay? Let's take a look at D before we look at C. Okay? D. We have a denominator, which means what? Set equal to 0. And in this one, yes, we are going to have to factor. But not the way we factored in A. What's that other way we factored? Who remembers? Ooh, okay. Yes. California for sure. Can you remember another one? Yes. Yes. California works every time, all the time. You remember? Next stuff out. Go. But when A is not 1, just look for 2 numbers that multiply to give you 12, add to give you 7. Positive or negative? Both of them. same way. California gives you the same way. What do I do here? If I set them both equal to 0, -4 and -3. So it cannot equal those. Put in your notation. And x is the element of what types of numbers?
Wait, what about the stuff on the top?
Doesn't matter.
Next to doesn't matter?
Now when it comes down to domain and range, it matters for other things, but not domain and range. I'm telling you, boy. Hard and not hard. Hard and not hard. All right, for C, we kind of have a double thing here. Not only do we have a denominator, but we have a radical inside the denominator. Okay, so that makes it just a little bit more, like a few more steps that we have to do. Because normally, if it was without the radical, we would just set the denominator what? Equal to 0. And if it was just the radical, we would just do what to the stuff underneath the radical? Greater than or equal to 0. But the thing is, it can't be 0 because in the denominator, and it can't be negative because it's underneath the square root. So what we do is, whenever we have these types of situations, we take whatever's underneath the radical, and because it's in the denominator, we just set it greater than 0. Okay? So, we have to solve this. So what we're going to do, we have to solve for x. So what do we do to that 9? Add it. How do I get rid of the square? Take the square root. Now, who remembers, whenever you take the square root in an equation or in an inequality, what do you get? No, your sign is a flip. You do get 2 answers.
Oh, plus or minus.
Plus or minus, whatever that number is. Okay? Together, boy, y'all. Strong. So it's going to be plus or minus, what's the square root of 9? 3. Now, these are the ones, now at this point, this is where I was talking about it becomes a little tricky. Okay? Because it's a quadratic, and the quadratic is because of the square, and it's inequality, I can't just put my sign down here. Alright? What we have to do, just stay with me, we have to make a little number line. Stay with me. Make a number line. Everybody make a number line. And put -3 and 3 on that number line. Okay? Now, our domain is going to be somewhere in these 3 regions. Okay? What we have to do is we have to figure out which of these 3 regions it is. Okay? What's the number that lies between -3 and 3? 0. What's the number that's smaller than -3? And a number bigger than 3? What we're going to do with these points is we're going to plug it into this right here. So everything I have written in purple, I'm going to plug it into this equation right here. If I plug in -4 and I square it, what is that? 16. What's 16 minus 9? 7. That's a positive number. That's a number that's greater than 0, right? So that means it is a part of our domain. Everything that's to the left of -3 is a part of our domain. When I plug in 0, 0 squared minus 9 is what? Is -9 greater than 0? No. So that means that between -3 and 3 are not a part of my domain. And when I plug in 4, what do I get? Same thing. Is it greater than 0? So everything that's in the check mark regions is a part of our domain. So everything that's less than -3 and everything that's greater than -3. That is our domain. How do you want to write it? good. That's that first part. How do I do this part? You need the union. You got it right. These are probably the harder of the group. That's why I saved that one for last. Okay? Yes. Because originally it was never equal to 0, so that's why they're not included. Okay? We're gonna look at 2 more, and then I'll save the last ones for tomorrow. That's tomorrow. Okay? How about that? So I'm looking at y'all. Y'all looking a little like, whew. I don't know, Miss Harris. I don't know how much more I can take of this. I think you can take 2 more examples, and then I think you might be like done on the goat part.
Well, I thought you were using interval without.
You mean set?
Oh yeah, I just said.
Yes, set would be the inequality version of this. Okay? So everything less than -3 and everything greater than 3. So that would be the set of x values such that x is less than -3, x is greater than 3, and x is an element of all the numbers. I know probably about equal, like level wise to write. We're gonna do 2 more. Then I'll save the last ones for Wednesday, and I'll let you guys get a chance to start on your homework. How's that sound? Sounds good? Okay. Ready? You guys got it. Okay. E. Square root. What do you know about square roots? Greater than or equal to 0. Very good. It's not in the denominator, right? So I still have the greater than or equal to 0. This is very similar to the last one we just did. How do I solve this? What do I do? Add 4. Square root. And whenever you square root, you have to remember what? Its square root of 4 is? Am I making a number line here? Yes. And the reason why we're making a number line here is because we're trying to figure out which one of these 3 regions is it actually defined. Okay? So I'm going to pick some test points and plugging it back into this part. Give me 3 test points, Tanner. Give me 3 test points. 0. And 3. I want you guys to test them right now into this equation up here and tell me, don't tell me out loud, but write it. Which one is a part of the domain, which one isn't? And if you can write it in set or interval notation, I'll let you choose which way you prefer. And write. -3, it work? 0? 3? So, how you gonna write it? Parentheses? This one's actually gonna be with brackets. There's a difference between this one and C. Say it a little louder. It was equal to 0 here. And because it's equal to 0, that means that the 2 and the -2 are actually going to be included. Then what do I need? And then as a class, bracket or parentheses?
Bracket.
2, infinity, and then? Wonderful. Teamwork makes the dream work. Yes.
On the last one, you set it to 0 or greater than
You talking about C? Oh, you talking about F? Ooh, look at that. is going to be greater than 0. So we got 2x plus 6 is greater than 0. I want you to solve this out, and then I want you to write this in both set and interval notation, the domain. Solve it and then write it in set and interval notation. So we have 2x is greater than negative 6. You divide it, yes? So x is going to be greater than negative 3. Right here, I can go straight to set. All I got to do is add my extra, right? The set of x values such that x is greater than 3, and x is the element of what? All real numbers. And Seth, end this out for me, right? Can you write an interval for me, please? Interval for me, please. Seth. Yes. Very good. Okay? So let's recap all of this very quickly. Okay? Especially when it comes down to algebraic, because I feel like mapping and graphing, you guys were good. Okay? So, when you have a denominator, you set the denominator equal to what? Equal to what? 0. When you have a square root, just a square root, you set what's underneath the square root greater than or equal to 0. But if you have a square root in the denominator, it's what? Just greater than 0. When do you have to use the number line? I heard a couple of things. I heard plus or minus. When, yep, yeah, you're right, when there's a radical. But more specifically, what? It's being squared. Your variable is being squared. That's when you have to do your number line and check. Okay? So make the necessary notes to help you remember that, especially when it comes down for your homework. Okay?